Check. 1, 2. Are you hearing me loud and clear there? Come on my computer and interfere my computer away. Right now, my two sons here. So I don't know what's going on. Are you hearing me? All right. So I'm saying this is 2021 paper, and that is one of the best ones to revise from right now, seeing that the syllabus changed last year. And they kind of, but the changes are big enough. The changes that they take out functions. So advanced students, you can just ignore functions. Certain parts and functions still there. You're seeing this is a function. So what I really pick out is like the composite and inverse things that already tested in maths. They're like, already getting tested and that, forget that. So we can learn from the previous past papers. Also, the previous past papers give you options. And there's no option now. You have to do everything. And I think last year the probability, what it came, this is last year probability space diagram catch a lot of people off guard. So make sure you know all the different things in probability and all the different things in statistics, all the different things that could come, box and whisk and web and whoever and kind of thing. Right? Make sure you know everything. So I go through this, and you'll get to see me remember this in a very, very cold thing. I feel like I do this paper like twice already. Maybe with my class I did it twice or once, twice or something like that. But that's good. Other than that, it's been a while since I've done some stuff. Determine the remainder when f of x is equal to that is divided by x minus 1. So okay, so the remainder of according to the remainder term would be f of 1 would be equal to the remainder. So I could put a by 1 plus to be cubed plus 7 by 1 to be squared minus 7 by 1 minus 3 is equal to the remainder. Let me just put this on the next piece here. This is really the remainder. Determine the remainder. So what is giving me something in terms of a plus 7 minus a minus 3. This is a minus 3, a minus 3. All right. So a minus 3. So the remainder is an algebraic statement. A minus 3. Y'all with me on that so far? How many of y'all would have touched this paper before? So definitely revise remainder theorem, factor theorem. What they normally do in remainder theorem is give you something that will end up into two simultaneous equations. Like remainder is da, and you have this something, remainder is da, you have a and b, and then you solve. That's the most common thing with remainder and factor. If the remainder, when f of x is divided by x plus 3 is equal to the remainder, determine the value of blah blah blah, find the value of a. So when f of x is divided by that, you get this same remainder. So we basically say that f of negative 3 is equal to f of 1. And we already know f of 1 is a minus 3. So I'm just going to put the negative 3 in this now. So I'll have a by negative 3 cubed plus 7 by negative cube squared minus 7 by negative cube minus 3. This should be equal to a minus 3, right? So this is negative 27a plus 63 plus 21 minus 3. Let me calculate that. I need to have this there, because things going to get drastic inside here. And is equal to a minus 3. Something so I get. So if the remainder of this, when yes, putting negative 3 in all these spots. Let me hope for the best. So I am saying this is like 28a, and if I bring across all these numbers, get this will turn to positive, so I can cancel off that. So I'm getting I don't know about you, but I'm getting 84. So a is equal to 84 divided by 28. Somehow I don't remember getting this answer. A is equal to 3. I'll get an answer. Whatever. So if I make a mistake, I'll just correct it in the comments so they know the drill. But these days are going mistake free for a long while. Let me see if I could not if I could come through clean here. Consider the functions g of x is equal to bloom, which has real and equal roots. Use the discriminant of the given equation to determine the values for m. You may use the grid provided to assist you. How about no? I remember this. I didn't use the grid, so I was like, nah, bro, no grid. So whatever the discriminant of the given equation to determine the values of m, the discriminant is b squared minus 4ac, right? This is our discriminant when in the form, when the quadratic equation is in the form ax squared plus bx plus c. And what the discriminant does is, remember this part is the part that is underneath the quadratic equation, plus or minus b squared minus 4, which is negative b plus or minus b squared minus 4ac. So whatever, in the quadratic equation, wait, where I get this paper from, boy? This paper come with answers. No, I mean if it come with formulas. But y'all know what I'm talking about, right? This is the discriminant here, and if this is negative, you had to end up finding the square root of a negative number. That means the root's imaginary. If it's positive, the root's real, meaning if it's greater than 0. And if it's equal to 0, is identical roots. So they say that the roots are real and equal, so it means that, so for equal roots, b squared must minus 4ac must be equal to 0. So in this case, what they're trying to say is m plus 4 squared minus 4a is 1, c is 4m, must also be equal to 0. So m plus 4 squared is m squared plus 8m plus 16 minus, this is 4m, minus 16m is equal to 0. So what are we getting? Again, m squared minus 8m plus 16 is equal to 0. So I'm getting m minus 4 and m minus 4 equal to 0. To determine the values of m, which has real and equal roots. So m is just 4. M is just negative 4. M only has one value. Yeah, so m is therefore well, m is positive 4, sorry. M is equal to 4. Why isn't it chat if you understand? Why I mean yes? How are the revision going? Let hx be equal to 2x squared plus 8x minus 10. Express hx in the form. So we want to complete the square. So take out the 2x squared plus 4x minus 10. You're going to look up how to complete the square. Find half of this and square it. Half of 4 is 2 squared 4. And realize that you're putting a 4 here, so we need to take it out. But actually, putting 2 times 4 here, I'm going to take out 8. And then I'm going to get 2x squared. I'm going to find half of this now, x plus 2. Because I created a perfect square here, minus 18 in the form a into x plus b to b squared plus c. So hopefully that's good enough there. State the minimum value. The minimum value occurs when minimum value of h of x, when the x plus 2 is equal to 0, and x is equal to negative 2, and f of x would be equal to negative 18. Well, not f of x, h of x. 18. So this is state. So I should really just pull this over here. The menu. You understand what I'm saying? Y'all know this part, right? I kind of speeding through this part. This part's supposed to be easy. Just now, I'll explain. So remember, when you complete the square, you get, usually it's written like this: a into x plus h to b squared plus k. And the minimum value occurs at negative hk. This is the minimum point. And what they essentially ask us in the question, they ask us for the y value, or the value of h of x, and then they ask us for the x value. So you want negative 2 for the x value, and negative 18 for the h of x. All of that making sense? Why is it in the chat? Very good there. See somebody say check over something fast. You can always pull back and review. So this is some stupid logs question here. Let me see what's going on with loggy boy. Find the value of a. Once again, there's no log. There's no. Let's see what's going on there. This is the second time I see this. I think I talked to this about my class too. This was the second time I saw this in a CXE paper, where these people just leaving out the base, boy. What's the meaning of that, boy? What's the meaning of that? Why they keep leaving out the base, boy? Why they keep leaving out base? I don't know what that paper. Why they keep leaving out the base by CXE, why? So most likely this is supposed to be log to the base 10, right? So if this happened in your exam, just write assume log 10 equal log to the base 10 of 10. This is 1. I feel that's what they're saying that. So log 2 6 plus root 12 minus log 2 3 plus root a, something looking good here, equal 1. Find the value of a. Well, this is subtract, and when you're subtracting in logs, log of a minus log of b is equal to log of a over b, provided that the bases are the same, right? So this is really the log to the base 2 of 6 plus 12 over 3 plus 3 equal 1. And when you're in this format, you could do a couple things. You could change it. Remember, I have a few videos on logs that will help pure math students and advanced students. Are like really nice videos. Press like on the video, people, that show you what logs really do, right? So like the log to the base 10 of 10 is 1. The log to the base 10 of 100 is 2. The log to the base 10 of 1000 is 3. So what is really stating, reviewing some logs, so just reviewing things as it pop up, is that 10 to the power of 1 is 10. By the way, 10 to the power of 0 is 1. 10 to the power of 2 is 100. So this is like going by between exponential form and logarithmic form. Logs basically tell you that how many times do I need to multiply this number, the base, by itself? How many times do I need to multiply the base by itself to get this number? You understand? So how many times do I need to multiply 10 by itself to get 100? So that's why if I put log to the base 4 of like 16, then how many times do I need to multiply? This answer is 2. That making sense? All right. So in other words, I could always rewrite this as log to the base 2 of 2 as well. And then I can remove logs, because I have logs heading up both sides. So I could say removing logs. It's a powerful thing to say. Don't just say that lightly. If you're hearing children screaming in the background, like my children, then they do them thing. So 6 plus, they in the student right now. So 3 plus root A is equal to 2. So we dropped off the logs. And now we ending up with, I just tried to turn on this thing. We're ending up with 6 plus 2 root A. Is making sense to y'all? 6 plus root 12. Why we need to be like this way? Did this say to go to any decimal place? Find the value of A. Is it that the 6's will cancel? And you get I'm getting square root of 4A over square root of 12. That making sense? So like I make this 4 and then square root it back. So I could sneak in the 4 inside there. 6 drop off. So A is equal to 3. I drop in the square roots now. 12 is equal to 4A. So A is equal to 3. Yeah, I just kind of squeeze them in. Why isn't each other if you all understand that? A little piece of mental gymnastics went on there. I hope that wasn't too much. Everybody cool with that? History? Yeah, so I'll get sort of that. So determine the set of values of x. So we need to multiply by the square of the denominator. One of the reasons we do this is because we're not too sure if the denominator, if we multiply by the denominator, if we multiply by negative or positive. So we capitalizing and everything. This topic is called inequalities. Multiply by the square of the denominator. And you'll end up with 4x minus 9 over, let's show you we can 2 minus x. 4x minus 9 greater than 0. So one of these will cancel and I'll just end up with 4x minus 9 and 2 minus x is, well, I keep saying greater, is less than 0. So this curve looks like this, I believe, because the 4x by negative x will give me a negative a. So this curve is doing something like this. Let's get the roots. Either 4x minus 9 is equal to 0, so x is equal to 9 over 4. 9 over 4 is like 2.25, or 2 minus x is equal to 0, so x is equal to negative 2. So negative 2 is actually smaller than negative 9. It's positive 9 over 4. Oops. So negative 2 is smaller than, is less in value than 9 over 4. And now we want the situation to be that we want all the values for this that's less than 0. So it's under 0 in this spot and in this spot. So you could solve this on the Casio as well. So the solution is x must be less than negative 2, or notice I don't have the equal to signs here, so I'll leave it. X must be greater than 9 over 4. This is two separate spots, right? So you can't join it up like somebody has it join up in the chat. The only time you have it join up is when, like this, is when the spot is sandwiched. So if it's two separate spots, you need to write it like this or suffer the consequences. X negative 2, x is positive 2. All right, so it's still not going to really affect where I have the 2. Okay, that's going to mean I was going to lose maths. That's stupid. All right, x is 2, guys. Let's stay woke. 2 minus x, yeah. X is 2. How many of you all agree with me on that? So, but remember, don't try to state it in one. Use sets notation for or, just write or. Well, you have to put a u here. Like a u, yeah, you can put a u there. This mean or. Yeah, that's okay. Right, so Alice deposited. I really like these questions, why I had to do this question. Alice deposited 4,000 into a new savings account at the Bank of Fortune, blah, blah, blah. 8% per annum. The bank compounded interest is represented by this progression, where A is the amount of money accumulated after T years, R, T, per annum, and T, a positive integer, the time in years. Determine the number of years it would take Alice's money to triple. So triple would mean triple 4,000 is equal to 12,000. Woo! Tough piece of maths we get them day. So we want the amount of time for the amount to reach 12,000. That's it. That's it. All right. All right. So they just put 12,000 is equal to P. What's P? 4,000. 1 plus 8% per annum. Triple, so we want 3. 3 is equal to 1 plus 8 over 100 equal T. What's the best way to get rid of that, to bring down that T to we level, boy? Maybe hit him at the loggers. So now we hit him at the logs. T, let's not jump the gun. Log 1 plus 8 over 100 T. So since there's this rule with logs that says if you have like log base A M, you could say base A log of A to the M is equal to M log A. Very power law now. Then you can bring down that T log 1 plus 8 over 100 is the same as 1.08. And so T is equal to log of 3 divided by the log of 1.08, which is how much? How much you'll have for that? So that good 14.2. Determine the number of years. So this is 14.3 years. Well, assuming that the interest is compounded at the ending of the year, is calculated at the ending of the year, it would take Alex 15 years. Y'all find that going too slow? Y'all want me to go faster? 15 years. So with these questions, if you have 14.3, if you get the year and there's a little fraction in the year, you usually need to round to the highest number, because you could compound it annually, and compound it at the ending of the year. Keep the space good. All right, so the coordinates for the center of a circle is 2, 1, and the coordinates for a point on its circumference is 3, 3. Determine the equation of the circle in the form, blah, blah, blah. So I would definitely try and sketch this circle just to get a little visuals on them. A little visuals on them 2, 1 at the center. A point on its circumference is 3, 3. This is like 2, 1. We want a point on the circumference to be like 3, 3. So somewhere here. So my circle doing something like this. Not the best circle I ever put on this channel. It's not the best. I'm giving them a best study. Holding back on that best. So the center here, and then the circle there. Wait, that circle horrible. Right? I'm gonna shift them up to represent a little better. All right. So what's going on? You want circle. How is do circles by? The circle is like x minus a to b squared plus x minus b to b squared is equal to r squared. where r is the radius. So we can do this natural way. I'll do it this way and just bring him down into this format, keeping in mind A and B is the center point. Or we could figure out this A and this B that they talk about. This A and this B here is not the same as that A and B. That's normally in the book you'll see this represented as F and G, and sometimes you see negative here and all kind of thing. So this is not the center. So it's probably best to do it like this, but make sure and draw a diagram where A is equal to 2 and B is equal to 1. But we also need to get R. Sorry, yeah, this should be Y minus B. I made a mistake there. We should also get R, the length. So R, I can do it here one time. R is equal to the square root. And remember, this is like a XY here of x minus a to b squared plus y minus b to b squared. Pythagoras theorem, right? Well, r squared is equal to that, so that I'll bring across the square root. So this is the square root of 3 minus 2 to b squared plus 3 minus 1 to b squared. So this is the square root of 1 squared plus 2 squared, so the square root of 5 units. Why is in the chat if you're all okay with that so far? So square root of 5 units, like a little 2 point something. Yeah, that making sense. That making sense. So we have R and we have A and B. So now we could just say, therefore, equation of circle and any right line would be x minus 2 to b squared plus y minus 1 to b squared is equal to the root of 5 to b squared. Notice how I didn't bother to change this into decimal because I'm going to square it anyhow. And then we're gonna mash it up so it could come like this. So this is going to become x squared minus 4x plus 4 plus y squared minus 2y plus 1 is equal to 5. So you're going to put x squared plus y squared minus 4x minus 2y plus 5 minus 5. Okay, so this turned into 5, and you have 5 on the side, so it just equals 0. So why is in the chat if you all understand that? That making sense with everybody. That's cool. The circle intersects the x and y axis at 3 points. Yes, yes, yes. So we're expecting a point here, a point there, and a point there. Right? So 2 points on the y. Well, I don't know what to expect, bro. I don't. Explain how this square cancel off. No. You have to go and research that. Research this. Write this down. Research that. Determine the coordinates of the 3 points of intersection. Or it could be that I just skim 1 point. Maybe you do this. Maybe do something like this. And it touch thing, and it skim 1 point. Something like that probably went on. All right, so how we determine the coordinates of intersection? When, so at the x-axis, y is equal to 0. Got him. So at the x-axis, y is equal to 0. So therefore, this thing here will change into x squared plus 0 squared minus 4x minus 2 by 0 is equal to 0. So you'll have x squared minus 4x is equal to 0. X into x minus 4 is equal to 0. So either x is 0 or x is negative 4. At x-axis y is equal to 0. Yeah, let me try the next one as well one time. At y-axis, the x would be equal to 0. So you will get, so it cut through the origin. I see like a little origin, vibes going on here. So you get 0 squared plus y squared minus 4 by 0 minus 2 by 0 is equal to 0. So, no, y is not 0. 2y is equal to 0. You get y squared minus 2y is equal to 0. So y minus 2 is equal to 0. So y is equal to 0 or y is equal to 2. X is equal to 0, x is equal to 4. When x is equal to 0, y is also equal to 0 in this. It's very easy to see. So this is a point 0, 0. When x is equal to 4, you need to figure out what y would be equal to. So 4 squared plus y squared minus 4 by 4 minus 2 by y is equal to 0. How much is this? 4 max. That's why that's happening. All right. Okay. Where this going? So 4 squared, 4 by 4, y squared, y minus 2y equals 0. When x is equal to 4, 4 squared plus y squared. No, come on, Cohen. You can't get tired already. 4 squared minus 4y, 4 minus 2y. Y squared. Something weird happened here. When x is equal to 4, 4 squared plus y squared minus 4 by 4 minus 2y is equal to 0. When y is equal to 0, x is equal to 0. So I'll have an x 0, 0. So this is a repeated point. When y is equal to 2, 2 squared plus, this is what I do last time, right? 4 x squared plus 2 squared minus 4 by x minus 2 by 2 is equal to 0. So x squared minus 4x is equal to 0. X minus 4. So I eat again x is equal to 0, x is equal to 4. So again 4, 2. Oh, okay. So again, you point 4, 2 here. And again, you point 2, 4 here. No point again here. When x is equal to 0, when x is equal to 4, 0, 0, 4, 2, y is equal to 2, y is equal to 0, 4, 0. Okay, let me double check it. X squared minus x squared plus y squared minus 4x minus 2y. There you go on, bro. X squared plus y squared minus 4x minus 2y 0. So I get the 0, 0. I get the 4. Yeah, I get that. 4, 0. Well, x is equal to 4. Why am I going back and repeating this for? I cycling myself. Yeah, I get the 2 points there. I understand what's happening there with me. Yeah, I was playing myself. So this is 4, 0. and 0, 2. So 1, 2, already repeated, 3 points. So 3 points are 0, 0, 4, 0, and 0, 2. So what I was doing was I got the point, and then for some reason I went and tried and substitute it back again. But I already know y is 0, so I don't know why I substituted back again. So I substituted back again, y is 0. Circling. But yes, so this is the correct answer here. 0, 0, 4, 0, and 0, 2, 0, 2, 0, 2, 0, 2. Yes, are the 2 points. Yes. Okay, so let's go again. Draw the equation of the tangent to the circle at the point 3, 3. So now we know, now we have a good description of how the circle should look like. The circle is looking like this, and we want a tangent at the point here. Did I say draw? They asked to determine the equation to the tangent. So all we need is the gradient of tangent. And to find this, we need to find the gradient of the normal, which in this case would be, this is the point 3, 3 up here. And this is, what was the center? 2, 1 or 1, 2? I think it's 2, 1. 2, 1. So we just need to find the gradient of the normal. Now this is a very, very common question here. So you find the gradient of this. Let's call that like M1 then. The gradient of the normal, M1. This is equal to normal thing for gradient, change in y over change in x. So this would be 3 minus 1 over 3 minus 2. So this is 2, the gradient is 2. So gradient of tangent, let's call that M2 then, must be equal to negative 1 over M1, which would be negative 1/2, negative reciprocal. And now we have the gradient and we have a point, so we could solve, right? So this is M2, by the way, gradient. So therefore, equation of line. The equation of the line is going to be y minus, I'm just using this method, m into x minus x1. Substitute point on the line and the gradient, or you could use the y equal mx plus c and find c, whatever floats your boat. This shouldn't be x1, this should be 3. Why is my nose tickling? So now this is y minus 3 is equal to negative 1/2 x plus 3 over 2. So this is y equal to negative 1/2 x plus, this might be 9 over 2 or something like that. And that's good. So bring across the 3, 6 over 2, 9 over 2. How is that for you all? Why isn't each other for you all understand that? That's good with everybody. Oh, they're trying to donate money to me. No, keep all your money, keep all your money. The position vectors of 2, or to earlier, the position vectors of 2 points P and Q related to the origin, relative to a fixed origin, or are given by, I read in my own thing right now. OP, OQ determine the unit vector in the direction PQ, giving your answer in the simplest form. So PQ to begin with would be equal to OQ minus OP. So this is negative 4, 1 minus 2, negative 3. And this is negative 6 over 4. And then the magnitude of PQ, because we need that to find the square root of negative 6 to be squared plus 4 to be squared. So the square root of 36 plus 6 plus, right? Yeah, plus 16. So equal to the square root of something 252. Or to over that way, giving the answer in the simplest third form. So this is 4 by 13. So equal to 2 root 13 is the best we could do. But that's not what I want. That's just the magnitude. It's looking like the square root of 13. I want it to be 2 root 13. That's the best we could express it in straight format, right? Don't go into decimals. And therefore, the unit vector and PQ would be equal to, oh Jesus, PQ divided by the magnitude of PQ, which is, you need to just divide these things by that. So this will be like negative 6i plus 4j. I'm just writing it like this for now. 2 root 13, which in the end will break down to be negative 3 over root 13 and over 2 over root 13. Why isn't it chat if you all agree with that? That making sense to everybody? I'm trying to double check my stuff as I go through it here. Because it's on YouTube now, I don't want to leave any mistakes up. Okay, well, you tell me if I'll just settle with that. So given that cos of m and the angle m is acute, very nice. Cos of m is equal to 24 on 25. Is that common triangle? This is m. Cos is adjacent over hypotenuse. It's 24 over 25. What will happen here? Determine the value of tan of 2m. Tan of 2m, how do we solve this? To begin with, what's the double angle formula for tan 2m? Just a little recap. Now, all of this given tan of a plus b is equal to what? Isn't it something like tan a plus tan b, or 1 minus 2 tan a tan b? Double check that for me. Tan of a plus b. That's correct, right? Yeah. So therefore the tan of 2b, or the tan of something like 2m, will be 2 tan of a 2 times the tan of m over 1 minus 2 by tan of m squared. Tan of m, tan squared m, 2 tan squared m, yeah, because they ended up with tan of m here, tan of m there. So, all right, but we still need to find what tan of m is. So we still need to find this missing side, because tan is actually the opposite over the adjacent. So according to Pythagoras' theorem, it's something like 25 squared minus 24 squared. 25 squared is 625 minus 24 squared, and you will get 49. So this is actually 7. So this is a special triangle where this is 7. By Pythagoras' theorem, this is 7 units. So tan of m, therefore the tan of m is equal to 7, not 7, sorry, 7. 7 over 24. So we just need to substitute now. So tan of 2m would be 2 by 7 over 24, all over 1 minus 2 by 7 over 24 to be squared. Opposite over adjacent, right? Yeah, cool. And what are we working out to be earlier? Cause mean really a time to, you know, do that now. So multiply by 1 minus 2 by 7 over 24 squared. What are we getting with that? Geez, and ages again, something very ridiculous. Now, if I get this in the exam room, I will be terrified. I will be terrified if I get that. Did I make a mistake? And I'll see what I do. I cancel this with. So, not supposed to have 2 there. You're supposed to have 2 there? Yes, it's supposed to have 2 there. No, it's not supposed to have 2 here. But that 2 come out from that 2. Who tell me to put that 2 there? I was remembering this too. All right, let me try again. Yeah, boy. I did it. Sing. So I guess in 2. We're sticking too long. 7/24 divided by, wait, it's 1 minus 7/24 squared. Right. This is sounding like something I'm familiar with. So this is 336 lion crime 527. That's what you'll get. I saw that in the chat. 3 something like that. 336 527. 336 527. Yeah, so I don't know why I put in 2 there. Tan of A plus tan of B over 1 minus tan A tan B. Tan of A plus tan of B over 1 minus tan A tan B. Where that 2 coming from? As we remember in this 2. So yeah, that 2 messed me up. I apologize. So that's scrappy. These are working there, people. Apologies. Differentiate sine of x. Oh, we should do differentiation. Sine of x plus cos of 4x with respect to x. Fine. If you insist. So a few things. We could say let y be equal to sine of x plus cos of 4x. And then we could say dy dx is equal to cos of x minus sine of 4x. Well, multiplied by the differential inside the brackets. And I could explain this using the chain rule, which is something that we tend to advise students to do in this level, and at maths level. So since so cos 4x can be represented as we can let u be equal to 4x and say du dx is equal to 4, and therefore this is cos of u, and let y be equal to this, so dy du is equal to negative sine u, so dy dx is actually dy du by du dx. So this is negative sine u by 4, which is negative 4 sine, and I replace the u back with the 4x, right? That's what we get at. So this is the chain rule application here, explained, just in case they want to mark you on that. But you really should be able to do it in your mind. Differentiate 2x cubed plus 2 with respect to x. These quotient rules thing. So we might as well square. So normally if you have like a v squared, I advise a square before jumping into it wholeheartedly. But I feel we could jump into this one time. I could say using quotient rule, and I would state the quotient rule. State it. U is equal to 2x cubed plus 2. So du dx, differentiating u with respect to x, would be 6x squared plus 0. And v is equal to 2x plus 1. So dv dx is equal to 2. And v squared is equal to 2x plus 1 to v squared. So this is I don't know if I want to do this part, but this is what this will be. I don't know if I want to put it in this form or that form. I'll see. 3 marks. Okay, may have some breaking down to do. So this is dy dx is equal to u dv v du dx minus u dv dx over v squared. That's the quotient rule, guys. Somebody asked where cos gone. Look at here. This is the answer here. If you asking where cos gone for this piece of move, whoo! Problems. God, no, that's what you're asking. So this is 2x plus 1 by 6x squared. See, we point in these questions, right? 2x cubed plus 2 by 2 all over v squared. Feel about 2x plus 1 to b squared. Now, they never really says simplify. They say differentiate and technical. This is the answer. The answer right there. But you could do some little simplification of the numerator. I will leave that as an experiment up to you all. Yeah, we'll get a cube here, and we'll get a cube here to play with. And we get a squared. I don't think anything happening with that. Let me see if anything happening with that. I don't think anything happening with that. Nothing happening with it. That's the right idea. That's the right idea. Yeah, so you can just simplify this slide by expanding to secure the bag, but technically, if they take away marks away from that, is slackness. Yeah. Use the principles of differentiation to compute the stationary value. So at the stationary point, dy dx is always equal to 0. If I differentiate this dy dx, I'll get 2x minus 4. So at the start point, 2x minus 4 is equal to 0, so x will be equal to 2. Why so much maths though? Okay. Big yawn there. When x is equal to 2, y is equal to 2 squared minus 4 by 2 plus 2. Negative 2. So stationary point 2, negative 2. Stationary value. And they didn't really see coordinates, so I just write that in case they're trying to be technical now, boy. I don't understand why it's 4 marks. Very sus. Very sus. Very sus. Very sus. Why is that 4 marks? Okay. So a motorist starts from point X and travels 60 meters due north to point Y at a constant speed of 4 meters per second. He stays at Y for 35 seconds. And then travels at a constant speed of 10 meters per second. The average speed of the whole journey. They want us to plot this eventually. No. If we could plot this. Field plotting. This is a good idea. Travel 60 meters due north to a point y at a constant speed. Or we plot a distance time graph or speed time graph. He stays at y for 25 seconds. Calculate the average speed. And travels at a constant speed of 10 meters per second. Due south to a point for 100 meters. Let me do a distance time graph just to get a gist of what's happening here. Let me do a distance time. Am I wasting time by doing this? Maybe. So, and the reason I draw up and down is because I realized he went 100 south and he only went 60 north, so this graph will go underneath the graph too. So he travels 60 meters due north to a point y at a constant speed, 4 meters per second. He stays for 25 seconds. 25 seconds. And then he went south, constant speed of 100. Something like this. That point Z. Constant speed of 10 meters per second. This one is 4 meters per second. Something like this ain't happening. He travels 60 meters. So this is 60 meters here. And this had to be 60 and this had to be 40 here. Why isn't it chat if you understand my little sketch? Average speed for the whole journey. I need the length of the journey. So average speed. The direction of the distance is not important. So one of these, I just need to add all the different distances, and one I do not. Because that's what they say now, average speed and average velocity. They're trying to see which one it is. They are trying to trick me, and it is working. Oh, which is which, right? Average speed for the whole journey. So speed is a scalar, so speed we really care about, no distance or anything. We just want to know what is this my average speed for the whole journey. So I would say he went up 60 and then he went up 100. So the total distance is 160. And the total time for this journey was 25 seconds. I need to find out the time here. I also need to find out the time here. So time 3 and time 1. So for time 1, remember speed is distance over time. So time is the distance over this little speedos. So this time 1 here would be the distance 60 over 160 meters is the total distance. 60 over 4. What time is good at 12, 15, 15 seconds. And the time here would be distance over speed. Increase the speed, decrease the time. So distance was 100, not 1,000, but 100, divided by the speed of 10. So time here is 10 seconds. So total time is 15 seconds plus the 25 seconds standing still plus the 10 seconds. So this is 50 seconds whole journey. So far so good. Why is the chat so far so good? Everybody okay with that? So we have the total distance. The distance doesn't take direction into account. So I would say the average speed is 160 divided by 50, whatever that is. .2 meters per second. We don't care about the direction, so you don't need to see anything. And the average velocity, the next kettle of fish. So the total displacement is actually 100 minus the 60, so 40 meters south. Yeah, you must use the rest time. The rest was part of the journey too. If you don't use the rest time, you will licks. So total displacement, at the end of the day, the car only went down 40 south. We don't care how we go, we just care about the direction at the end of the day. So, and the total time remains the same. So average velocity would be actually 40 over 50, 4/5, 0.8 meters per second. But this one you need to say in the direction of point. In the direction, in a southern direction. Right, so you need to state the direction in this, otherwise you're gonna lose max. Another way you can state the direction is by making use of the negative sign. Maybe I would prefer if you just write this and put in a southern direction. Integration now. So integrate this. The integral of that is what, by 2x cubed, and you divide by the new power plus 3x squared, and you divide by the new power plus c. Don't forget the plus c, folks. And the integral of this one would be equal to negative 2 cos 3x. We need to divide by the integral of what is in the bracket, the differential of what is in the brackets, which is 3. So, they get your 3 marks for this. Yeah, they should be working. It always had to show you working in CXC for this. So you could do a back. You could show them a back working. You all remember this? Since if I have y is equal to a sine bx, dy dx would be equal to a b cos x, where you multiplied by what's the differential of in the brackets in the term. So is the chain rule in application, but it's going back up. Yeah, I didn't finish it. I have to be in the plus C. Big up Jared. But I don't think I'd finish it. So don't hold it to me. So what else to explain this by? Well, when you differentiate something like this, right? Let's say you differentiate 2x plus 1 to be squared to the power 4. When I differentiate something like this, you end up using the chain rule, and you'll have to multiply by what's I call the differential of inside the brackets. 2 by 2x plus 1 cube, and then you multiply by the whole power. So it's 2 by 4, so you end up with 8 2x plus 1 cube. So you end up multiplying by this power and what's differential of inside the terms, because they're chain. So if you go back this way, You do the same thing you normally do when you're integrating by dividing, but you'll also need to divide by the same differential of inside the brackets. So even if it's like sine 2x, you need to consider this as a nested function. So you need to divide by the 2. That's why I ended up dividing by that 3 there. Why isn't it chatting for you? Okay with that to some extent? Using an integration method, calculate the area. Let me try that again. Using an integration method, y is equal to 3 sine x. This is the graph of sine x. The graph of 3 sine x will just stretch a little more. So you could just make it a little stretchy. The first quadrant will be here. So this is pi, this is 2 pi. This is pi and 2. So it's bounded between pi and 2 and 0. That's the first quadrant. So to find the area, you put y is equal to 3 sine x, and then you put integrating y with respect to x between 0 and pi and 2. So you do the same thing here, integrate between 0 and pi and 2, 3 sine x. Well, integrating sine x, you already know you're going to get negative cos x. Excuse me. So you get negative 3 cos x. Put the negative on the outside and the 3 on the outside. And you get pi and 2 and 0. So you just need to substitute that and done. Now you can do this whole thing in a calculator like this. Shift. Once you have definite integrals, you could put the entire thing like that. 3 sine. Oh, yes, you're tired. And then you put in your limit 0, pi and 2. Now, those of you all in my class, please go back to the class where I showed you all the different classes, where I show you all the different tricks that you can use that with this calculator to solve. My calculator in degrees. Oh God. I don't know why it gave me this whack answer. 3, yes. This supposed to equal to 3. Equal to 3 square units. That's what I'm going to do. Now, they didn't force me to work in radians. I could have worked in degrees, but radians is the go-to now. A particle starting from rest travels in a straight line with an acceleration a given by a is equal to t squared. T is determine the velocity v of the particle in terms of t. Well, you start off with displacement, you integrate, you get velocity, you differentiate, sorry, you get time. And if you go back this way, this is integrating. Integrating, and this is differentiating. So where are we? We are on, did I put a here, t here? I wanted to put a. So all of this is being done with respect to time. So you differentiate displacement, you get velocity. You differentiate velocity, you get acceleration, which once you differentiate with respect to time. So you take very well. Starting off with acceleration is equal to t squared. So I want to integrate to go back up to velocity. Integrate a with respect to t. That's really v. If I integrate a with respect to t, I will get t cubed on 3 plus some constant. A particle starting from rest, so that means starting from rest, at rest velocity is 0. and the time was 0. So at v t cubed 3 plus c, when v equals 0, t is also equal to 0. So 0 is equal to 0 over 3 plus c. So c is also 0. So therefore we can you always need to check over the parameters to, these questions to get rid of the c. We use our initial value, popular. So therefore, I want to say v is equal to c is 0 in this case. So you didn't need to put like +1 or anything. It's just 0. Next, calculate the place to this any time interval between t is equal to 0 and t is equal to 2. Calculate the displacement. So I can work out the displacement. Tired, so I can work out the displacement. Or I can integrate between t is equal to 0 and t is equal to 2. Yeah, I can integrate that. I can use a definite integral. No, I know. I could keep integrating and substitute the. Let me see. So I integrate this again. Integrate v with respect to t, and that'll be t to the power 4 now over 3 by 4 is 12. Again, chaotic, and the integral of that is s. This is plus c. I can put k now since I use c already. Is equal to t to the power 4 over 12 plus k. Calculate the displacement of the, so when s is 0, starting from rest, when s is 0, t is 0. Yeah. Excuse me. When s is 0, t is 0, or when t is 0, s is 0. Therefore, k is also equal to 0. Similarly, like how we get the constant, it will be equal to 0. So we start, so it's just s is equal to t to the power 4 over 12. And when t is equal to 2, s would be equal to 2 to the power 4 over 12. 2 to the power 4 is what? Not 16. 16 over 12 is what? 4 thirds, 4 over 3, 1 and 1/3. Third units. Why isn't it chat if you understand most of that? Is it that we're going to do the last question here now? Because I'm real tired, bro. I feel internet didn't do this last question now kind of thing. Yeah, but the Casio way better than the Sharp. At least the Casio that I'm using here way better than that common Sharp that is using. 2 fair tetrahedral dice with faces numbered 1, 2, 3, 4. Tetrahedral dice. That is a dice like tetrahedral dice. And how the dices look. The dice have 4 faces on it. It's a kind of, and I feel I know how the dices look. So create a sample space, all the possible outcomes. So it's sample space table, and this didn't come in a long while. 1, 2, 3, 4 on this dice. And you could do like 1, 2, 3, 4 on this dice. Anything like that would work. You need to label though. So you need to put like die 1, dice 2, and diagram of probability space. And this will be 1, 1, 1, 2, 1, 3. This making sense, Joe? 1, 4, 4, 4. 4, 3, 4, 2, 4, 1, 2, 1, 3, 1, 2, 2, 2, 3, 2. Falling asleep. 2, 3, 3, 3, 3, 4, 2, 4. Why isn't it chat if you'll understand? So that's the probability space sample table. Does it look like that? Yeah. Use your space table created to determine the probability of obtaining a 4 on both dice as 1 out of 12. Only one situation. Only one such probability out of 16 outcomes. So the probability of obtaining a 4 on both dice is 1/16. At least one die. The probability of obtaining a 4 on at least one die is 1, 2, 3. At least one, so you're paying this one too. 4, 5, 6, 7. So there are 7 such outcomes. Because they say you could use the sample space. So from sample space, 7 such outcomes like this. So the probability of 4 on at least one would be 7 out of 16. Why isn't the chat if you all understand everything so far? We coming to a close. Praise the Lord, because G's and ages, man. The probability of obtaining a 4 on exactly one dice is the next one. How many times that happened? That happened 1, 2, 3, 4, 5, 6, 6. So I just printed the probability of 4 on one dice. Exactly one dice. Would be 4 out of 6. 6 or 4. I hope it was 6. 6 out of 16, which is 3 eighths. 1, 2, 3, 4, 5, 6. It's I'm running out of juice, boy. I might have to come back and do these last 2 questions, and I've fallen asleep here. So, how will you make up with the studying thing, boy? The studying thing is very old. Show that obtaining a 4, which is not what we want to do in CXC, on both dice are independent events. For independent events, the probability of, let's say, a 4 on first dice, probability of A is 4 on first dice. And the probability of B is 4 on second dice. So the probability of A and B is equal to the probability of A just by the probability of B, just so. So the probability of A and B happening is 1/16. The probability of A happening 4 on the first dice. The probability of 4 on the first dice is 4/16. 4/16. 4 times, right? 4 times. Yeah, let me check it. Probability that I get 4 on one dice. The probability is a quarter. The probability that dice roll a 4 is a quarter. 4/16, yes. So 4/16 times 4/16 So 4/16 times 4/16 is the same as 1/16. A quarter of a quarter is a 16th, yes. So QED. So this is the best way to do this. Learn off that formula. Determine the probability of obtaining a 4 on both dice, given that a 4 was obtained on at least one dice. You see that given? As soon as you see given, this is the probability of A given B, and the probability of A and B over the probability of the given thing, given that a 4 was obtained on at least one dice. Probability of A obtaining a 4 on both dice. So this is, we already have this as 1/16 over the probability of B on at least, given that a 4 was obtained on at least one dice. This is a quarter. So this is a quarter. This is a quarter. Just use the formula for this one. Probability. Probability of 4 on at least one dice. Something wrong. Probability of 4 on at least one dice. We do that already. That's 7/16. At least one dice. 7/16. Oh, geez, and H's. This was 7/16, guys. Nobody didn't point out that to me. You're saying yes, sir. This was 7/16. So this is equal to 1/16 multiplied by 16 over 7. So 1/7. 1/7. Accept risk. QED means it's proven. QED means, did I write QED just now? Yeah, just do it absent-mindedly. Quadratic demonstrandum or something like that, and it means what has been asked to be shown has been shown. What has been asked has been demonstrated, or something like that. I mean, that's what is right for person. That's at the end of the day, if you write it. This question still have more parts. The score of 30 students on the mathematics test were used to draw the box plot below. Are you really panic thing here, man? Okay. All right. Median score. So you just need to read off that. A median score looking like between 10 and 12. Where is that? 11. Median score. Reading. Or from graph. From graph reading or from box and plot or anything, wherever. Median is equal to 11. 11 were figs, 11 mangoes, 11 marks. Excuse me. 11 marks. That is a score. The range of these scores was, range is equal to highest minus lowest value. So it was 20 minus 4, so it's 16 marks. The interquartile range, well, Q1 is equal to something, and Q2 is equal to something. Q3. Semi-interquartile range, okay. Q3 is equal to something. So let's find out what they are. Q1 is 7. This one is 17. Or maybe even, I mean, going through all of that. Yes, 17 minus 7. 17 and 7. So interquartile range is Q3 minus Q1 over Q3 minus Q1. So this is 17 minus 7, which is 10 marks. And the semi-interquartile range is half of the interquartile range. Half of 10 is 5 marks. Why is in the chat if you understand that? No, you won't get it wrong if you find the exact value. Shape, positively skewed. Median. Well, the median was closer to the Q, right? So positively skewed because you see a bigger amount on the positive side of life. So a bigger amount on this side of values touched. A student wants to determine the mean score for the data set. Last question. State one reason why it would be impossible to determine the mean score from the box plot. We don't have it. We don't have the individual. What's that noise? Individual score of values. Max. I think it's max is the best word. We have the number of people in the set. Yes, we do. So finding the total will so you need further information. I sleep right in here. Without further information, we can't find the total number of marks everybody have. And you need that and you divide that by the 2. Last part of the question, well, second to last part of the question. State one additional piece of information while the individual scores. Or we can get the sum of the scores. So you can get the sum of all individual scores. Now with this, you might get repeated scores there. So you might want to get the sum of the score and the frequency each one of the score was scored, so that you can multiply it. So and frequency in this case. Given the sum of the 30 scores for the class is 354. Determine the standard deviation. Standard deviation, advanced students, you should know standard deviation is the square root of the sum of all the individual scores minus the mean divided by n. Add a square something somewhere. Add a square is the square of the the square is this. You square all of these things, because sometimes when you're subtracting it, one will be higher or one will be lower than the thing and you get negative number. So you square it, then divide them there. Right. So that is really. So this was a hard question that I think most people got wrong last year, because they didn't give you it straightforward. Notice what they do. They give you the sum of the squares of the score, which is really like this part here, and they give you the sum of the scores was 354, which means we could find the mean. We could find the mean. Yeah, this is the formula sheet. So we could find the mean. So we could find this. Now this formula can be split. I show my class another way, but I was watching this another easier way to do. This formula can be split into the sum of all these scores divided by n, sum of all these scores squared divided by n, minus the sum of x bar, the sum of the mean the sum of the means, of all the means. Now, it only have one mean, but it's the mean multiplied by the number of times you're subtracting. So all the different scores, which is like n. So it's like n x bar v squared divided by n. Now, since you're dividing by n, the n cancel. So this is just really, this could be split up like, so I don't need no sum anymore. This is just the mean squared. So this is really the square root. And I don't know if there's a formula like this. I think there's one online. The sum of all these scores divided by n squared minus the mean squared. Yes. So similar with that, play around with it, plug in values, check, create your own equations, whatever, plug in values and see if it works out nicely. So substituting now, this would be the square root of 4994, the sum of these squares, divided by n, which is 30, minus the mean squared. The mean is 354 divided by 30 squared. This gives me what? What does this give me? So there's this guy, Darian Giuseppe. He's one of the top teachers in the student hub here. He teaches Pure Maths Unit 2. I don't know if you're all interested in that. You can check out his channel. He has a channel on YouTube. Miss Nalini teaches Unit 1. Well, she doesn't have a channel, but I have some Unit 1 stuff. You can check out my trigonometry stuff. Hello, everybody from India. Good luck in your exams. This may be a little easier than the exams that you are doing. The exams across there are pretty tough. Very competitive. 5.21, 5.2, too many standard deviation. They didn't tell you what a 5.22 to 2 decimal places. That sounds reasonable because if marks out at 20 and standard deviation like about 5.22, that sounds good. Yeah, Daniel, everybody, everything good. Blessings, people. So that comes to the end, I believe. Yes, that's the end of an ADMATS exam. How long does it take? 1 hour and 34 minutes. Anna talk plenty. This is the number to WhatsApp to sign up for lessons. +1868. Anybody going and do pure maths later this year? WhatsApp this number to sign up for lessons, some good high quality online lessons at the Student Hub. You can take a pick with the teachers. It's really good teachers that I screened. Or if you want to do ADMATS with me next year, I'm starting ADMATS in July. What else? Any subject that you want to do. Dinal is a student from the Student Hub. Yuan is a student from the Student Hub. You can ask them. It's the best class ever. Gerard is also from the Student Hub. If we get our next live tomorrow, maybe. I don't know if Rebecca is from the Student Hub too, because we have a couple of Rebeccas. This is the Caribbean. This is the Caribbean, bro. Yeah, then we can see. Yeah, Zaylene. I hope this studying going good. Yeah, then we can try a thing. So I don't want to keep you all any longer. Go and digest this stuff that I need to digest. Those of you who are not following me, which I doubt will be anybody, Crew and Springer. Those of you who are not subscribed. We reach that 100K. And until we meet again, yeah, man, big up Pakistan in the house. All right. Ting. Or you could go and watch over the crash course to people from my class. Later.